Okay, we're picking up where we left off talking about hypothesis testing. Specifically, we are doing an example. We're working through a simple example of hypothesis testing to determine the process of doing these little things and how to interpret the conclusions. As you noticed from last time, here's our problem. It has to do with one of those video rental kiosks. And one of those video rental kiosks has some data that we're able to get from the distributor, and we sample 40 records for such a kiosk and find that the average sales per day is 311, and we're going to assume a population standard deviation of 10 bucks. That's an odd assumption that we know the population standard deviation, but we'll go with what we have for this type of problem. Furthermore, this is a business problem, so let's use 95% confidence, which means a significance level of 5%. Now, first we want to determine average sales from this type of kiosk. This is a confidence interval. We find ourselves a confidence interval by going on to Microsoft Excel. Microsoft Excel, we have our problem information already entered in here. Again, note our critical value is here, and it's a two-sided interval, so that the area in the upper tail is 0.025 from a 95% confidence, so we get 1.96 as our critical value. We then calculate our interval. Our interval is down here, and our interval is nothing more interesting than the sample mean minus the critical value times the population standard deviation over the square root of n. The upper limb of our confidence interval is sample mean plus the critical value times the standard error. So what we have here is we have our confidence interval, and this is where we ended up last time. This confidence interval is from $307.90 to $314.10. This suggests that at 95% confidence we have a real good idea that the mean sales will be within this interval. Now, suppose the store owner wants to find out if sales will be around $310. Will it? Well, this is an hypothesis test. For now, let's assume it's a two-sided test, so the store owner cares whether sales will be more or less. That means that we will have a null hypothesis of 310 and an alternative that's built as this not equal to, so it's a two-sided test. Well, what we do is we take our null hypothesis of 310 and go look at the interval above. So we look at this interval. When ordered by size, does 310 fit between 307 and 314? Well, yes it does. That means that very readily could the true mean be 310. So we can report that we accept the null hypothesis. Furthermore, we can say we accept the null hypothesis, and it looks like the kiosk will indeed generate around $310 a day in sales. We should also, however, look at a test statistic and a p-value if we're doing hypothesis testing. So let's go back to Microsoft Excel and calculate ourselves a test statistic and a p-value. Okay, my test statistic is calculated down here. It's calculated by picking up the absolute value. I do like to use the absolute value on these things. The absolute value of the sample mean minus the null, and now I've put a null in here, 310, divided by the standard error. Standard error is the population standard deviation over the square root of n. That will give us this test statistic. This test statistic turns out to be, when it's working for us, there we are. Now my table is not complaining again. My test statistic is calculated as sample minus the null divided by the standard error. And that gives us a test statistic of 0.63. Furthermore, we calculate a p-value based on that test statistic. All a p-value is the area in the upper tail of the test statistic compared to the null. So it's 1 minus norms dist, that's standard normal distribution, cumulative distribution, of the test statistic, when it's already an absolute value. So I get a p-value of 0.263. Okay, so let's go back and take a look at what this means for our problem. We have a test statistic of 0.63. We need to compare that to the critical value from the table of 1.96, which we found in Microsoft Excel. But again, to remind you how you do it, you've got 95% of your confidence level in here, and the significance level has to be spread over these two outer tails. So the upper tail has the significance level divided by 2. Now, if this has 0.025, you can find the critical value by looking it up in a table or by using Excel as we did before. We do get that critical value of 1.96. Now, the way this test is to be done is to compare the test statistic to 1.96. Clearly, 0.63 is smaller than 1.96. A small test statistic means what? Well, it means that we accept the null hypothesis, meaning we can't reject it, and it does indeed look like the mean could be 310. Now we go off and look at a p-value. The p-value that we found out of Microsoft Excel is 0.2635. That needs to be compared to the significance level divided by 2, since this is a two-tailed test. So significance level divided by 2 gets us 0.025. Clearly, my p-value of 0.26 is much larger than that, and a large p-value suggests we accept the null. So both tests suggest we accept the null hypothesis, meaning that the population mean might well be 310. Now, what happens if we find out that the rental price for the kiosk is actually $310? Now we need to know if the kiosk will generate at least $310. Because if it generates less than $310, we won't be making any money. As a matter of fact, we'll be losing money. So now we're going to do a one-sided test. A one-sided test gives us a different format for the alternative hypothesis. My alternative hypothesis will have greater than or equal to 310, because that's what we care about. Now, you can't use an interval for a one-sided hypothesis test. You can go back and look at the test statistics, but you have to be a little bit careful about it. You've got to compare them to the right thing. So let's go back and take a look. We use the same numbers from the test statistic, but we compare them to something different. Let me explain why. If this is a one-tailed test, then 95% is in this area over here. The significance level is now going to be over in this side, but now all the significance level is over here. So I've got 5% over here, and if I've got 5% up here, I'm going to have a different critical value. Matter of fact, my critical value will be 1.645. So I need to compare my test statistic here of 0.63 to 1.645. Well, it's still significantly smaller, so I'm still going to accept the null hypothesis. What about for p-value testing for a one-sided hypothesis? Well, for a p-value test for one-sided hypothesis, we actually compare it to the overall significance level of 5%. Notice that's not 5% divided by 2, but 5%. So I take my p-value of 0.26, compare it to 0.05, notice that 26% is larger than 5%, and say, gosh, that implies that I'm going to accept the null hypothesis. All right, so that's my decision so far. I'm going to accept the null hypothesis. However, what does this mean? Does that imply that we should rent one of these things, or does it not? Well, what do? We've accepted the null. The null means it could be 310. Do we rent it? Well, no, we shouldn't. Why not? Well, we shouldn't because what we've shown is the evidence suggests that the rental might not be covered by the intake of the cost or the intake sales. Why? Because sales might be 310. I have not shown conclusively that sales will be greater than 310. The only way I'm going to make a profit is if sales are greater than 310. So I needed to reject the null hypothesis that it could be 310, and I needed to show that sales were greater than 310 in order to make a good, strong case for renting the kiosk and putting it outside our store. Otherwise, we don't make money. So I have a strong accept of the null hypothesis that it's 310, which means that I do not have good evidence that I am greater than 310. So do not rent the kiosk. Okay, see how that works? I've shown a couple of things here. I've shown how to set up a null hypothesis and an alternative hypothesis for one-tailed, for two-tailed. I've also discussed how to do the tests. I've shown it on Microsoft Excel. I have also talked about what to do with our conclusion, because a lot of the issues here are not just accept or reject. It's what does accept or reject mean? What do we do? What do we tell the boss to do? What do we go out and do? Well, that's what's so tricky about some of this stuff, so you need to think about it carefully. Well, I hope this has helped. Good luck.